Okay. Okay. We're live, and we're having technical issues. I didn't have my microphone on, so for people first watching that was wrong. It couldn't understand me, and we're trying to stream this in 1080p instead of 720. So our cameras look like they're not wanting to work with us. The computer probably just needs to finally be upgraded. Anyways, this MacBook is in here for a bad backlight issue. This was already taken to another repair shop where there was a little bit of liquid damage around the LCD connection where it plugs in. So the technician had just cleaned it with some isopropyl alcohol. That seemed to have solved the issue for the time being. However, the screen's still not working. So the customer brought it back to that other repair shop, and the repair shop told him it was a screen issue at that point, wanted to charge him $500 ahead of time before even ordering the screen, which I can understand that. We charge part deposits in order to order screens. $550 for a MacBook Air A1466 screen is a little relatively high in my opinion for a part deposit. That's almost the cost of a full price. But that's just a matter of preferences and running your business. Where I'm going with this though is they assumed that the screen was the wrong which is why the backlight was not working. However, in this case, it's actually a main motherboard issue. And so just to show you real quick that the backlight is indeed not working, if we can switch over to our overhead camera, if it wants to work, any second now. I promise this is gonna work. Oh my goodness. Okay, hold on. Let me see if I can switch this back to 720. This isn't working. Volume. There we go. Black. Okay, cool. What's up, Optimized Logic Repair? It's good to see from you. I am changing the resolution of these cameras here because they don't seem like they want to play with me today. Let's drop this down to 720. All right. And we'll just blow up the canvas, or to fit in the canvas. Okay, at least this one's working 1080p. Anyways, back onto here, we can see that the computer is completely black. So I'm gonna get my phone here and just put the flashlight just right underneath where the Apple logo is. And you can see that the display actually has image. So there's still something wrong going on with this computer here. So to figure out if this is actually going to be a motherboard issue or a screen issue, what you want to do is measure with your multimeter around the fuse, it's the little thing with the P right here, and see if it's actually putting out the proper voltage. Let's see. All right. So this is the entire area where the liquid damage was. In fact, we can still see some rust right here, some corrosion. Optimized Logic Repair says voltage on D7701. This one I've actually already checked, but we're going to check again, and it was about 8 volts, which tells me this is an issue with the actual backlight driver itself. But just for educational purposes, I'm going to take my multimeter and measure just right here where the fuse is, and we're getting 8.5 volts. Now what Optimized Logic Repair was talking about is voltage on D7701. I believe that is this diode. We are getting 8 volts on this side. I always forget what's on this side. 0.0. Okay. And this is part of our boost circuit, so we might actually have some more issues over here. We're going to pull out the board regardless, but we're not getting the right voltage. We want to see anywhere between, I'd say, 12 to 50 volts. So now what the next step is we're going to rule out that there isn't a ground. Well, if we had short to ground, then we wouldn't be pulling any voltage, or it would be pulling all the current. So what we want to do next, just to make sure there's not a short, we're going to unplug our charger, unplug our battery, put our multimeter into resistance, and then while our screen is still plugged in, just measure right where the voltage goes onto the LCD backlight. And there is no resistance, or I should say there's no short, no immediate short to ground. Sometimes in the past there could be something wrong with the T-con board or something with the actual EDP cable that could be shorted, but in this case it doesn't look like Yeah, boost comes from pin 6 on and 7 on U7701, which is going to be the backlight fuse. Or I'm sorry, backlight driver, my bad. So in this case, it does not look like that there is an issue with the screen. So the other shop, I understand the logic where they're coming from in this case. However, if they went through the process and paid the $500 for the screen replacement and it showed up, it simply wouldn't have resolved the issue because this is going to be more of a board issue. So without further ado, let's go ahead and pull the board out and see if they even clean the corrosion on the bottom side. Okay. So when doing any board repair, you want to make sure that you remove the SSD drive, just so that we don't mess with any of the customer data. I would check the connector as a matter of course. I actually did that ahead of time. I diagnosed this when they dropped off the computer, but I will show you the connector anyways, just underneath the scope. That is another good process of diagnosing. So the connector's still plugged in, and what I forgot to show, which I was suggested just now, is to actually just remove the connector. And what you want to look for is if there's any burnt spots right here. So this looks completely clean. It doesn't look like there's any crud or corrosion on the actual EDP connection going into the board. So in this case, this still shows that this is not an issue with the screen. This is going to be more oriented towards the board itself. So thank you so much for the suggestion. And let me just put everything on hold real quick while I answer a phone call. I'll be right back. Alright, and we're back. I just had a multitask phone call just now. This is usually the time of the day where everyone's getting off work and coming and picking up devices, or calling after getting off work. Alright. So let's set our housing aside. Okay, so let's take a look here. just to see what is or isn't left behind, and then we'll pull up our schematics. All right, so this is going to be our U7701, which is the backlight driver. This is what actually controls the brightness on the MacBook itself and sends the LED, or it sends power to the LED strips. Still trying to find a wireless mic setup. The XPD one is DC.
Hey, is this sir?
I'm not too sure about that one. XPD one is that the? I think that's Samsung. That's the same one we have as the PXD one. That's the one that we have. I did try looking for that. I actually, if my Amazon links work below, I was trying to add the microphone, but it looked like it was currently out of stock everywhere. Yeah, unavailable. That's what I thought. So looking around here, I don't really see any signs of corrosion. Then again, this was already previously cleaned. I'm just looking around the rest of the board. Well, we do have something here. We'll address that after we fix the backlight. We'll take a look at it before we fix the backlight. How about that? Okay, I don't really see any corrosion around there, but definitely a lot of rust. All right, let's go ahead and pull up our board view real quick. Oh, we actually have our board view pulled up for our 820-00165. This will be a 13-inch MacBook Air, either a 2015 or a 2017. So what we want to look for, if I can get my keyboard out. So we had a little bit of corrosion over here in the area, which is going to go to our CPU. So let's just clean up that area and make sure we're looking at the right thing first of all. Nope. Okay, cool. We're fine. It looks like we have some corrosion right here. Nope, still just as bad. We don't want to have these capacitors shorted. These are, this is what powers the CPU in the first place. So we need to just go ahead and kind of clean up this area to prevent any further damage. Yeah, this is actually really gross looking. This one looks like it's starting to split. So just to protect the customer from having a dead CPU in the future, we're just going to go ahead and replace these capacitors first before we actually take care of the backlight. I think that's just going to be a nice safe measure that we do before anything else. So
Sarah Dunn is here. I don't see a VIN number or invoice. You have it. Thought you were done with.
Wait, did you just call? Oh. I was like, wait.
I'm just adjusting my setup here so I can actually pay attention to the comments at the same time. Let's see. They have a new version C7796 would cause no backlight too. That's not what we were looking at though, was it? No. C7796. We'll take a look at that in a second. Hey, let's get on board real quick. Okay, so it looks like our stream's actually getting a little choppy. So it looks like 1080 is going to be really hard for this computer to handle. This computer only has an Intel Core 2 Duo processor, 8 gigs of RAM, and an all-right NVIDIA card. I think it's like a GTX 600 series.
Okay. Hey, why is this hard drive bringing up 330 and Sarah said it's 280?
We sold that computer to Sarah, so we're knocking $50 off.
Oh, okay.
Yeah.
We're just giving a discount.
Yeah, exactly. No, it's fine. I don't think I mentioned that to you guys. I didn't change streaming PCs, not yet. I'm waiting till Cyber Monday to stock up on some new parts to just go ahead and build an entire new computer. What I did here is I just changed the streaming output from 720 to 1080, and that doesn't look like that was a good idea. Did you get bit by an ant?
I like sanitized my hands with some hand sanitizer, and then all of a sudden it started burning. And I was like, "What? When did I get this?"
Ouch. Okay, so we just want to have this all nice and clean so that the CPU doesn't die in the future. Okay, then let's get our donor board over here to borrow some capacitors from. Were you able to get that taken care of?
Yeah, it's all good.
Okay.
Yeah, it's like it's something weird, so I just had to go move forward with the
You do hear voices. There's 4 of us right now. No, there's not 4 of me. There's 4 other employees, or 3 other employees, and then myself. And we have customers walking in too. Right after 5 o'clock, that's when we get our rush of customers picking up. That would be the boss, yes. That is my wife. Mm-hmm.
the same person.
This is the boss.
Oh, wrong direction. I went like the wrong direction. So shy, much shy.
Who are you? Oh.
Oh. That was me on the camera just now. Yeah, that was it.
Go back to your home. Let's add a little bit more flux. I'm cooking this one too long. Bye.
And I would consider myself more of an advisor, even though you like don't listen.
Well, that's why they say advise.
I know. Is that really on there?
No, it's not.
Okay, I was about to
I'm
say,
gonna
it
fix
didn't
it. Hold
look
on.
like-
Hold on. I think my tweezers aren't getting as hot as they used to.
You turn the heat up?
No, the tweezers are all the way up. I think there's something going on with the actual tips, because I'm having to use the heat gun alongside with it. I'm gonna make this look a lot prettier in a second. Don't judge me. It's just don't want to heat it up too much because the CPU is on the other side.
I've seen boards come in with it just looking like this, but I think we're fine.
Yeah.
Did you have any coffee?
I had coffee a while ago. It's just underneath the microscope, so everything looks shaky. So really what I'm doing, I'm trying not to heat this area up too much because directly on the underside is the CPU. So I just have the constant fear that we're just going to end up toasting the CPU. So what I'm trying to do is a method of heating up the capacitors with my tweezers and just the general surface area with my reflow workstation. Okay, so this side looks a little bit better. Now we just need to clean the area on top, and then we can get back to the actual backlight issue.
Okay, I'll keep you guys up to speed tonight. Oh man, yeah, I'm psyching myself up. Nice! Look. This is what my employees do. You still work there?
Yeah. I don't like the way that capacitor up top looks. Eh. Okay. Ew, why is it so crooked? Please don't judge me as a technician based off of this.
No, but when I was a busboy, I practiced like
Okay, the important thing is that the connection's on. It's not going to go anywhere. It's just not straight. And I shouldn't strive for too much perfection since we're directly underneath the CPU. Although this one cap down here looks like it's not all the way on. There we are. Oh, nope, nope. And okay, see, this is exactly what happens when you try to strive for perfection. This cap is lifted up a little bit. There we are. Much better. All right, let's get back to the actual board repair here. It's so crooked. It is not my best job. Anyways, back here. So, let's take a look at what Optimized Logic Repair says here, which is where's C7796? Ah, okay, so that's a capacitor right next to the EDP cable, which is where all of our corrosion was. So let's check and see if we have continuity to ground. Okay, so let's see what happens. Doesn't look like that is a clean enough connection to find out if it's even shorted. So if we touch right here and ground, it doesn't look like it, but let's check and see if it's partially shorted. So I'm going to change this over. Yeah, it looks bad. Yeah, we're going to go ahead and just replace it anyways. So we don't have a partial short anywhere. We still have an infinite resistance, or it looks like we just OL. So just as a safe measure, we're going to end up replacing these big caps just so that this doesn't come back in the future. And start working on that. Alright, we're going to need more heat from our rework station here. Alright, so for moving components like this, especially a capacitor where one side is ground, what I like to do is just go ahead and try to apply some flux or solder into the area, because our solder is a low melt solder, so it will help these capacitors melt at a lower temperature, the solder that's currently on there. And let's nuke the entire area. And these caps should just come off like that.
This phone is not loading. So if the battery's all the way dead, we'll tell it that we turn off. Continuing upload to the storage is full. So
Our donor board looks like it also had an issue with the backlight layer, our backlight circuit as well. There's some corrosion. Right here we can actually even see where the connection, or the LCI, liquid contact indicator, has been tripped. So let me get another board. Another thing I'm going to do is remove the Wi-Fi card, since we're going to be applying a lot of heat to that general area. Thank you. Okay, so now let's just go ahead and get some donor parts. So this is a healthy looking backlight circuit on a dead MacBook Air. So just like what we did a second ago, let's apply some solder to these components. That way that they melt much faster than they normally would with the solder that's currently on there. Probably going to take the diode too, just because the other one looked equally as bad. Thank you, donor board. Okay, so now let's get this ready. And let's put our tiny capacitor back on. That'll probably be the easiest one to work with. Hey, you know, Sam's right. My hands are a little shaky today. There's a method to my madness. We're not going to keep it like this. Okay, so now we're going to use surface tension to pull these components back together. Okay, so this capacitor is going back into its home like it should. Come on. The tiny one went. There goes that big one, and here comes the last big one. So it's a lot more aligned than it was a second ago, just by using a lot of flux and heat, and the surface tension of the solder just naturally brought everything over. Now let's replace this diode just because it looks equally as bad. It's kind of just like a windshield wiper method of just replacing everything. And this will also ensure that the circuit's not going to fail again by just removing the parts that already look very corroded. Okay, so now let's get our donor diode. Alright, so here's our donor diode. And just going to use the iron to solder one point on. And then to make it look a lot better, we'll use our rework station again. And just kind of let everything flow back into place. Those chips seem to be very sensitive. Oh. Let's see. Be a criming shame if we put a new U7701 and that little cat blew it. I know, right? That's why we want to just replace everything. I've been down that road before. And so, just for efficiency, that's why this windshield wiper method, I used the same thing back in the day with iPhone 6 backlights. It's better, instead of just replacing the part that's bad, just go ahead and repair the entire circuit. Cover your ground on everything. Alright, now let's just kind of touch up these pointy parts. Okay, now before I replace U7701, I'm pretty sure that's the issue. Let me just look at my schematic one more time to refresh myself. So we weren't getting any power on D7701, which is the backlight, the LCD backlight boost. So let's pull this up here on our schematic just to see if we can kind of get an idea of what's going on. Do I do an iPhone logic board repair? So in the beginning, we did do iPhone logic board repair just to get some experience. And we still offer like TriStar replacements, audio ICs, things of that nature. Now we just strictly do iPhone repair for data recovery. So like for the iPhone 10, 10s, I haven't done an 11 yet, but any of the ones where you have to split the board, we actually have the tools here to fix the short that's wrong with it, and then put it back together in the handy dandy, what is it, eye socket, which is hiding around here somewhere. Very handy. very expensive, but the eye sockets are great for doing data recovery. But putting the phone back together and having it working, we don't do that. We do it just strictly for data recovery. iPads, if it's a no power issue, we fix those typically between 150 to 250. Sometimes it's something as simple as a TriStar, or there's a short on the VDD main. But we're more of MacBooks, to be honest, than we are iPhones. But we do get more mail-in iPhone repairs for data recovery than MacBooks, I will say. Need to work on my marketing. Okay, so back onto our screen. Yeah, D7701 is going to be our diode, which is part of boosting of our LED driver. So if pin 1, what side is pin 1 on? Pin 1 is on this side of the circuit, and it wasn't getting any power. That's going to tell me that the power coming out of the LP8550, our backlight driver, it's not actually sending power to it to turn it on. So our issue, it looks like, is in fact going to be with our backlight driver is just simply not turning on. So let's just go ahead and replace this guy to make sure everything is working. So there is our driver. So whenever removing a chip that is a BGA, the ball grid array, what you want to do before actually pulling it off is you want to make sure the chip wiggles a little bit, and that lets you know that all points of the solder underneath are loose, and you can pull, let's just gently pick it up. I'm just thinking of this one incident where this guy that I knew was just pulling straight up on the chips and just ripping the solder pad points on the board straight off. It's hard to do that. You really got to pull hard. But see, like, barely touched it. The whole thing just lifts right up. So now, we need to remove all these balls. And you can do that either by wicking with your soldering iron, or wicking using your rework station. I've been using my rework station a lot more for this type of reballing, or wicking. So you just get a wick, put it on your tweezers, heat up the general area. The wick seems to grab the solder a lot better if you've already put some solder on it. So now our pads look nice and clean. Let's get it ready for a new backlight driver. Well, let's put a little bit of flux in here and heat it up. And get our new driver. So if you're ever doing chip replacement, IC replacement, and you don't know the orientation of how to replace the square, there are dots on the chip itself that tells you where pin 1 is located. So you can see right here, bottom left is going to be our pin 1. Just going to go ahead and lay that down for a second. Hands are really shaky, actually. Come on. Okay, so that dot on there, you just put my hand in a giant thing of flux. We'll clean that in a second. Here in the board view by Paul Daniels, each pin 1 has been color-coded with a red dot. So in this case, pin 1 is going to be facing our bottom left. So we want to make sure that the dot on the IC is going to be facing bottom left towards pin 1. And I've already gone ahead and done that. So now we're just ready to flow the BGA driver back onto the logic board. Now, I need to tone down my air so that it doesn't blow away whenever I try to heat up the area. What we want to watch is that the IC is going to just do a little dance and wiggle and then fall into place. It takes a little bit longer when you use less air, but I want to make sure this doesn't blow away. And then if I'm ever unsure if it's on there, I just barely touch it and it will wiggle. And see, in this case, the whole thing moved. It didn't wiggle, so it's not on just yet. See if we can add a little bit more flux to the area. Alright, I can see the solder balls are starting to melt a little bit. And just waiting for it to move into its home. And to be fair, I could have used a little bit more heat, so this is taking a little bit longer to heat up. But any second now, this should just slide over to the right side.
Night, everyone.
Good night. See you then. Or Sunday.
Yeah, hit me up tomorrow about that.
Okay. Okay, so it's all starting to slightly move over. Let me see if I can change my temperature over here. I had to switch hands. Okay, back onto this. Alright, so it very little. It moved a tiny little bit, so it's barely poking. See if it jiggles. It did. So this one is in its home. Yeah, this is my first live stream where I've actually attached the links on Amazon to the stuff that we use here, so I'm not sure if the links are working properly, but if so, the camera mount that I use should be on there. Just for good measure, I'm going to hit this one more time with a little bit more heat. I want to make sure that all the balls are properly soldered in place. Okay, I'm happy with that. Okay, so let's let the board cool down for a minute before we put it back together. and test to see if our backlight's working. Let's see what's going on. I need some Mac Mini schematics. I actually haven't worked on a Mac Mini. I know that there is a technician in the Discord, or the Rossman Discord, who's working on a 2012 Mini that one of the components was ripped off and he couldn't find the schematics. I'm not sure if they actually exist. I personally haven't looked. Cool, awesome. I'm glad that the links are actually working. I spent a lot of time setting that up the other night, just because I've had a lot of people ask me what camera equipment we use, so I figured it'd probably be a little bit easier. I still have some things I need to add onto there. Let's see, where's this computer? Alright, now let's just briefly reassemble this to test that our backlight is working. Then we'll give it a ultrasonic cleaning afterwards, since we have flux everywhere, but also because this was previously liquid damaged, and since the tech working on it did somehow get it working just by kind of scrubbing the area, we want to make sure that if there is any corrosion hiding somewhere else, the ultrasonic cleaner will find it and fix it. And I'm not worried about the keyboard at this moment. Really, I'm not even worried about the speakers. Really only care about the backlight. So let's plug in the LCD. And just to make sure that our computer is turning on, we'll plug in our fan. And that is the bare minimum we need to show that our LCD is working. Alright, so let's turn on the computer and see if we get anything. Alright, screen just went black. I'm holding Option to try to get the Option boot to pop up. Oh, you know, I even said I unplugged the keyboard too. Oh, that's funny. Oh no, it's fine. I don't take any offense to my hair. I have not had a haircut in a while. I think I had a haircut just shortly after COVID had started. Nothing. But my hair is just getting a little long. I'm probably going to rock it and try to get it down to my shoulders. Okay, that's enough of that. So I don't have the keyboard plugged in, which means I'm pretty much just waiting for this to show a question mark. That's all I'm waiting on at this point. This is what you get for trying to cut corners. I end up having to wait anyways. Oh, and look at that! It didn't work. Oh, interesting. Okay, let's see what's going on here. It looks like we still have a further issue. I'm going to change the orientation here while the screen is on, just to see what exactly is going on with the computer, because we are still missing our backlight. No, I figured as much. Where my camera is, it's always, my hair is always getting in the way. I have to look over the board, so I've noticed that in a couple of my videos. Okay, so let's see what voltage we have on our backlight fuse. Yeah, we're getting 8.5. Okay, let's check our diode. One side we're getting 8.5. The other side we're still getting 8.5. Backlight, oh no. Okay. And then let's check and see where our backlight actually goes in on this computer, on the LCD, what voltage we're getting. Still 8.5. Okay. Time to check traces. Oh, I took no offense. Slowly losing my hair, but I take no offense. Mm-mm. I'm gonna try one Hail Mary before I start looking further. See, in the rare instance, very, very rare, I doubt this is gonna fix it, but if this needs a PRAM reset, that'd be nice. I don't think that's gonna fix it though. If I could do a PRAM properly, I was hitting Control Option PR instead of Command Option PR. Mm-hmm. I don't think this is gonna fix it, but I just want to make sure I'm covering all my bases. Okay. Still nothing on the screen, so there's still something else going on. Yep, there is a little error right there. Arrow. So I just wanted to see. I've done that one time where a computer just needed a PRAM reset after putting it back together. Oh, that flew away. So now we actually got to get smart. And in order to test this, we're going to need to get a LCD that's already out of its housing. Because we're going to need to get some measurements around RU7701. Alright, let me go look for a screen real quick.
That's what bothers me. It's just I'm really competitive.
Let's
Every time I would play with them, I'd be like, guys, can you actually play? What are you looking for?
CD so that I can test out the backlight. Alright, so let's study our schematic here. Start from the beginning. So, PP bus is going to come through F7700, which we've already checked, and there is 8.6 volts on it. So that's perfectly fine. Then it's going to go through a voltage divider right here, which is turned on from this MOSFET right here in particular. Once it's turned on, it will then send PPVN SO LCD backlight FET. So let's take a look at this area to find out if our Q7707 is even turning on. Alright, so that tiny little guy right here is our Q7701. So according to our schematic, if LCD backlight enable L, if this is a low voltage, or really, if I understand this correctly, if this sends this all to ground, then the divider works. So really we need to be looking at Q7706 to find out if pin 3 has a voltage that is less than 12.6 volts. Or I guess less than PV bus, which is 8.6. Okay, so pin 3 is right here. And hoping my multimeter is turned on. We're getting 2.8, so that means that our voltage divider is working like it should. Make sure that there's nothing in between. Pin for 8.6. So PP bus is right here, which then is going to go through this MOSFET, which gets turned on once the voltage divider from this MOSFET is turned on. So this is doing what it needs to do. So now if we check pin 5 and 6, which is right here, this is going to be your PPVN SO switch. LCD backlight, are you working? 8.6. Which would make sense. So 8.6 is right here. And once this is lower, because this is a P-channel MOSFET, so since this is lower on the gate, and then source and drain are going to open up. So 8.6 volts is then going to go through Q7706. So now this part of the MOSFET let's see, where does this go? Not that much information on where this is on the schematic. It just says that it goes right here to the shunt resistor, which then hooks up to LCD backlight driver input. It just current sense. That's all that this is just current sense, which then sends SMC LCD backlight in sense. I don't think this is where our issue is going to be at. Let's check and see. 1 second, I'll be right back. We're back. So, yeah, I don't think this is where our issue is going to be. So let's look elsewhere and see, first of all, if our driver is even getting the proper voltage, if PP3V3SO and PP5VSO is going into our driver. Just awkwardly moving my board around. This is going to be something stupid, like I don't have all the balls in the driver properly on all the way. Okay, so according to our schematic, PP5ESO is going to be down here. Let's make sure that we are getting that much power. Yep, so 5 volts is going in. I would check the trace above D7701. That goes to the other side of the board. That trace is for feedback. If that is broken, U7701 won't know to boost voltage. Okay. I'm thinking something simple, like I just didn't add enough heat. It took a while for those balls to move into place, so there might be just one ball that's not properly soldered on as well. Probably something that simple. Your method's probably correct too. All right, now let's check and see if we have 3.3 volts up here. Yeah, that's working. Fan.
The fan?
Yeah. Bad hard drive, fan. I've also heard the power supply make some weird clicking noises. Yeah, that's one reason why we don't work on consoles anymore, is you have to keep so many parts in stock to work on them. Okay, so Optimized Logic Repair was saying let's check the trace that's right above D7701. Let's take a look at that just because that seems like a logical step. Let's see, where is that? You talking about this trace? I don't think so. Okay. I gotcha. Yeah, there definitely is a niche for console repair. Okay, let's see. Because this one's actually new to me when you're talking about this trace. So between ball 5 and that probe point on the other side of the board, a bit tricky to check. That is hard. Then we have to remove the driver then for that. Because ball 5? Oh, that's very tricky. Okay, there's not even a test point right there. Okay. Let me detach. Nope, below that one. Okay. So sorry, let's see. Nope, below that one, above the coil, to the left. Hold on. Sorry, I'm being pleased, bro, right now. Let's see what's going on. Alright, so you said above the coil, to the left. Alright, so here's our coil, there's our diode, to the left. This tiny, tiny little probe. So you're saying that we should probably check, it is a little rusted, this probe to pin 5 on U7701. That is tricky. Just before I start making a fool of myself, let's even just check and take a look at these balls. Yeah, they look like they're pretty soldered on. Just want to make sure I didn't do anything stupid. Where? Nope, too far. Okay, let's see. Where's my finger? There it is. Okay, those balls look alright. And those balls look alright. Alright, let's figure this one out. So, I'm going to do a little bit of cheating then. I started to watch your videos just today, learning something. Awesome. Curious how to do it yourself. Honestly, watch plenty of videos. If you're very curious into board repair, check out logi.wiki, logi.wiki. That is ran by Chris at Shiny Computer. There is a collaboration of technicians from the Rossmann Repair Group that just add very helpful information. Also, just join Louis Rossmann's Discord. That is a very, very great place to learn how to start doing board repair. You can even pay to be on their forum, Rossmann. I think it's boards.rossmanngroup.com. I've learned a lot of things from there as well. But first thing is just buy a couple of donor boards and start watching some videos, study schematics, and practice yourself. Practice on donor boards or boards that were liquid damage but not turning on. You might actually be able to fix them yourself. Don't automatically start working on customer boards. That is just don't do that. All right, back on what we were talking about. So what I was thinking about cheating here, let's see, yep, use continuity. Just because it is in such a weird spot, what if we just solder a tiny little wire right there that can wrap around to the other side of the board? Yeah, you're very welcome. I'm still learning myself. And I've been doing it for a little over a year and a half, 2 years now. But you're always learning. Never think that you're that there's no room for improvement. All right, so I'm gonna solder a tiny little wire right here to go on the other side of the board, so I can just have it held over on one side. Where is my wire? Actually, hold on. Let's see, I already have a pre-cut wire. Yes. An A1466, which is like this. That's a MacBook Air 2012 to 2017. Those are really good boards to work on. This wire is way too big. This is probably taking a lot longer than if I just probed it myself. It didn't look broken. The trace didn't look broken. So Manuel, the very first thing I would recommend if you're doing trying to troubleshoot where the issue is if you have the schematics for your specific board, you're going to go off the 820 number. Check your power rails, your power aliases first, and check and see if they're present. That'll give you a better idea of what's not working. Wrong camera, I just realized. Ooh, yeah, that's a little hard. You can get a cheap microscope for about $200. That's what I started on before I upgraded to something a little bit larger. Okay, so I went ahead and just soldered a wire right here that's going to that trace. So now we can just touch our two parts together and see if they have continuity. So if we hear a beep, then everything is working. I don't think my probes are small enough. So what we'll need to do to cheat is there's a via right there. That via is going to go to the other side of the board. So we'll be able to actually just scrape right here to expose where the via goes. Alright, and I'm going to touch the black probe onto my wire I made, and red on here. Yes, so we have continuity on both sides of the board. So that doesn't look like that's the issue, thank goodness. So let's remove that wire. That was a fun little experiment. Good to know for future reference. I appreciate you sharing that information. Okay, so let's see. Backlight enable. Let's check and see if that's even being told to turn on. So that's going to come from PPVN SO LCD backlight, which goes through this resistor right here, R7731. R7731 is right next to our driver. Let's check and see if there's an enable signal coming from there. I found a problem with PP bus G3 hot on F7140. No continuity. 1 second, well, I'll be right back. Did that have a hole in it? Wait, go back to that resistor. Hold on. I don't even know what I saw. Let's see. It does look like it, doesn't it? Right there on the left. That might just be junk, though. Let's find out. Is the resistor resisting like it should? Alright, supposed to be 200 kiloohms, and measuring with my resistor right now. Oh, I'm sorry, you can't see what I see, because I changed to the wrong camera. 1 second. I'm sorry, I don't have any neat buttons to change everything over quickly. Ah, come on, hands are way too shaky today. Alright, 100, slowly climbing for some reason. Definitely reading weird. So that's probably where. Well, let's not get too excited yet. Let's go ahead and send some power through it.
Does she have to be hooked up to Wi-Fi, or is this something she can leave with?
What is she doing? I'm sorry.
We're restoring from the iCloud backup.
You want it to finish restoring from the iCloud backup which shouldn't take too long, typically about 5-10 minutes. But once it gets to the home screen, she's good to go.
Okay.
But if you interrupt it now, that might mess everything up. Okay, just needed to plug in my broken screen. Okay, so I'm just going to measure on pin 2 of this resistor. It's in style. Oh, sorry, my hands are way too shaky for this right now. We're getting 2.8 volts. Later, Jerry. See ya. Sorry, my English and Chilean. Oh, okay, sorry, you're talking optimized logic. My bad. This one is taking a little bit longer than I thought. How does this keep happening? I'm sorry. I don't know why my camera keeps going to the wrong channel. There is a little bit of crap right there on that resistor. Let me just compare it to my donor board. Well, my donor board equally has a lot of crap around the backlight as well. Okay, that resistor's still reading about the same. The resistance on here was 200. And according to our schematic, that's what it should be. Nope, never mind. Now it's in the 2 megohms. What? Okay. It looks like it's got a hole in it. We're replacing that. What about R7716? R7716? Where is that one? This resistor still looks bad. I'm going to end up replacing it anyways. R7731. But you were saying something about R7716. Where is that located? R7716. Oh, okay, just a little bit above it. I don't know. Did that one also look like it had a hole in it? No, I think the flux just made it look bad. Let me go back. Wrong camera again. Yeah, R7716 looks fine. This one doesn't look like it has a hole in it. It's reading 90 ohms. If we check that to our board view, still going to end up replacing R77, what was it, 31? Yeah. Schematic says 90 kiloohms, which is exactly what we had. All right, I'm going to replace this R7731. I think that's potentially where our issue is at. Yeah, it's not the best camera. It claims to be 14 megapixels. It's more like 5. My wife, she has a Sony Alpha, I think it was the revision 7, and that thing's got like, hold on. Sony Alpha 7R4, which has like 60 megapixels. Be nice to have that. Thought I saw something. No, and I appreciate you troubleshooting, especially through a video too. You're on a much higher status than I am. I'm finally getting to a point to where I have a dedicated customer service guy. I have my wife here is kind of does a little bit of everything, and then I got a dedicated Mac guy who just does like the generic screen and hard drive replacements. So now I'm finally getting to the point I can focus on more board repair. That is not pretty. Why is this so bad lately? All right. It could be a bad U7701. It also could be soldered on wrong because I don't like how long it took for that to heat up, or for it to move into place. I feel like there's one ball that is preventing everything from turning on. So if this still doesn't work, I might just give it a reflow and then potentially replace it. Okay, let's see what is going on. Let there be backlight. Nope, nothing yet. Yeah, alright, this one's still not turning on. Let's give U7701 a quick reflow, just to make sure all the solder balls are properly on there. Not, then we'll go ahead and we'll replace it one last time. And from there, if it still doesn't turn on, we'll have to get even smarter. Okay. How ironic would it be if I put the LED backlight driver in the wrong orientation after showing a quick representation of how to put it in the right orientation? Or the donor board that I got the other component from, the other diode, what if that was actually the issue? There's a couple of different things here in the works. Alright, so that's moving like it should. Okay. Let's see if that fixes it. Because remember, if you get PP bus on D7701, U77 is not boosting. Oh, okay. You're right. Okay. Nope, still no backlight, and this did turn on. Alright, before we replace the U7701, let's check something else out. Feedback line, we did make sure that that was perfectly fine. Right. Okay, so PPVN SO switch LCD backlight, that's going to be our 8.6 or PP bus line, which then turns into PPVN SO switch LCD backlight, which is going to go through our coil. So pin 1 on D7701 is going to be 8 volts, and if everything works just fine after the feedback, I'm hoping I'm saying this right, this should be about 50, probably actually higher than that. Okay. Let's make sure this isn't blown. Or I should say, make sure the diode's working like it should. So a diode should only let, it should only beep on one side. Okay, so the diode's perfectly fine. So let's go ahead and change our U7701. It may potentially be bad. What's up? Which device? Is it her 7? Whose?
It doesn't matter, just the server. How do I set it up to get it to automatically back up?
Through.
Midnight contract.
Go into iCloud, and under iCloud settings, make sure that iCloud backup is turned on. Okay. Yeah. So go to their name. Okay. Now, if you scroll down to the bottom, there should be something that says iCloud backup. iCloud backup. There is an iCloud Drive, which is different than iCloud backup. Okay. Alright, so now that we have our driver pulled off, let's go ahead and wick up these solder balls. Need just a little bit more flux in order to pull up some of these balls here. And if we replace it one more time, I'm thinking what I'm going to do to make things a little quicker is treat this as an iPhone and compare the actual solder pads with a known good board, or one, I shouldn't say known good because all I have are dead boards here, but get diode measurements and see. Ooh, a lot hotter than my last time I did this. And the output is much higher too, so that's why my flux keeps disappearing. I'm on the cusp of fixing this one. We can head out after that. Okay. Thank you. You. For taking care of that one.
Oh, yeah, that was perfect. You know, I just wanted to see, because she had a 32 gig phone, and it was full, and she said it was running slow, so she turned the phone off, and it never came back on.
Yup.
So it couldn't boot back up. So she had a backup from like January 5th, or I'm sorry, June 5th.
Yeah.
So I was like, that's a smart thing to go. And the thing is, she just had bought a 200 gig plan to back it up.
Uh-huh.
When she turned her phone off, it broke it.
Oh, man.
So yeah, no, I told her, I was like,
Yeah.
set up to where it will automatically back up for her now.
We've been getting an influx of those lately,
Yeah.
especially with iOS 14 being out now.
Well, it's just people got their data on it.
Okay. Oh. See, this is what happens when you have a little bit too much heat or air. The chip will try to move all over the place. Ah. And I wiggled my chip a little too much. Hands are too shaky today.
Man, that's a big close next door, like now. Someone just walked in. Like 5 minutes, I guess, before the store.
To the salon or pizza?
Oh,
Well,
different company.
alright, so we got a replacement backlight driver on here. Let's see if that resolved the issue. It's very possible we could have got a dud because I did just get a new batch of those drivers in, and I'm hoping I ordered the right one. Leave it to me to not order the right one. No, those are the right ones. So it's very possible that one's just bad. Okay, let's put this back together and see if now we have backlight. Let's see, how long has this stream been going on? I feel like it's been, yeah, hour and a half. This one's taken a lot longer than I thought it would. Okay, do we have a working backlight? Nope, still nothing. Alright, let's see what we're getting on D7701. So we still have another issue going on here. Yeah, so we're getting PP bus through here. So something still isn't boosting. And we've already tried the driver. So let's look back at the schematic. Come on, backlight, tell me about it. Okay, so we tried the backlight enable. Oh, I didn't realize there was another resistor. Okay, so this is a voltage divider right here too. Oh, where's this resistor? R7715. Let's go back to here. Now that I forgot to measure the voltage after I changed R7731. Okay, so 2.8. That is a voltage. I don't know if it's the right voltage. So let's see if we can do some math here. Okay, so we have PPVN SWSWL or SOSWLCD backlight, which we know is 8.6, or it's PP bus essentially. And then we're going to have a resistance of 200 to 100 kilo ohms. So at this point, I'm going to have to actually just pull out a voltage calculator and make sure that that's right. Okay, where is my screen? Where did everything go? Okay, so voltage, voltage drop calculator. Yeah, it is copper. It's not actually a wire, but I think that doesn't really matter for what we're doing right now. It might, so 8.6, it is DC, single number, or single set of conductors. I think it's just 2 in parallel. Really? They're not in feet. No, they're not even in meters. Okay. This isn't what we want. This is not what we want. This is not what we want either. Nope. I don't think this is what we want. Am I looking up the wrong thing? What is going on here? Like, I want to say 2.8's right, but I don't know. I almost feel like that's not correct. Let's try this one. Inch calculator. Yeah, this isn't what we want. Okay. There's one voltage calculator that we've done before that actually made sense. There's a whole bunch of formulas that I should know. I really need to start studying up on just electrical engineering. There's a couple of technicians I've talked to who've been doing that, and that seems to really help them out, because I must be just looking up the wrong thing. Why does everything keep disappearing here? Okay, so looking back at this, we know that this is about 200 kiloohms. Is this one actually 100 kiloohms? Let's measure that real quick. This is probably perfectly fine and just a red herring. Mm, 90, close enough since it's on a voltage divider. So let's keep looking around before I pull off the backlight and then start doing a test on the diode test. Backlight power management. Let's take a look here and see if that's actually getting power. So it looks like over on, this is the long way of doing it too. Let's make sure that R7704 is getting the proper power. We're getting 1.4 on this side. On this side, nothing. Now, that could be because of ground, maybe? .8 for backlight enable is too high. So you think that the voltage divider probably isn't chopping it down like it should. None of the resistors look like they should. They're putting, or resisting the right way. Okay, thank you. I appreciate you opening up a MacBook Air for me. Yes.
Okay.
This resistor is supposed to resist 33 ohms. We have 33 ohms, so that's working like it should. And then the other side, let's see what's going on. Other side is just ground, which would explain why there was no voltage on the other side. Oh, wait, I'm sorry. Hold on. No, that actually doesn't make sense. EDP backlight power management. We had 1.4 on one side, but then nothing on the other side. But it's a resistance of 33, which is barely anything. So we should still have some sort of power over here. There's no short on C7704. Maybe that resistor is bad. And just to make sure, this right here, yeah. Make sure that that's not shorted. Yeah, no, that's perfectly fine. So let's go back here. Alright, so this is pin 2, which oh, I just wasn't probing hard enough. Okay, we're getting 1.4. False alarm, so that's working like it should. Alright, back onto the schematic. Okay. What else do we need? We have a clock, and we have data, which is going to be these resistors. R7716, which we already checked, and R7714, which is part of, that is not part of our data, sorry, it's part of iSet. Clock and data is going to come from the SM bus PCH data and PCH clock. Would that have anything to do with why the backlight's not working? Let's check it out. So both these are on the right side, and they're supposed to have resistance of 0. Basically, these are fuses. Alright, so put this into voltage. 0. 0. Alright, so our clock and our data line are working perfectly fine. Okay, let's see what else we got going on. We have our backlight filter also has a resistor right here. Let's see if that is being, if that is working like it should. C7741. So it says it has a resistance of 10 kiloohms, and that is directly below our U7701. 9.9. That's close enough. Okay. VSync. I don't think VSync has to be present, but we'll check it anyways. R7755. It's to the right of our backlight driver. And that's going to have resistance of, what did we say? 10 kiloohms. Yep, 10. 2.8 is correct. Thank you, Optimize, for looking into that for me. That really helps out. I appreciate you taking the time of disassembling a working board for me. It really helps. Manuel, the flex board view does not include schematics. That is a gray area question. I would just recommend Googling. That's all I can say. Okay, so back on to our schematics. So we have VSync filter. I didn't check backlight iSet. I checked the F-set. So 7714, why not? We're testing everything else out over here. So that's supposed to be 21.5 kiloohms. 21.5, right on the money. Basically at this point, I'm just checking everything that's on here. We know that our backlight clock and data is fine. Backlight power management was fine. Backlight enable was fine. Backlight fault. Who? Oh, yeah, no, George was excited.
Yeah, she said she was just nervous.
Aww.
Yeah, like she didn't care about anyone else.
I figured as much. Yeah. I apologize, Manuel. That's just a gray area question. Okay, so backlight fault. That is just a test point on the other side of the computer. Is there crap there that might be grounding everything out? Could that potentially be something? Let's take a look. These are new parts of the backlight circuit that I've actually never looked at before. Oh, and Manuel, just as a heads up, this one part of my screen looks very good. Just wanted to share that. Okay, so where's that test point? That test point is this thing right here, which looks perfectly fine. Let's check and see what its resistance is. Yeah, looks fine. Let's check and see if there's any power on this line. There's not. And I have a feeling there's not supposed to be power on this line. Okay, let's take a look and see what else. So everything that seems to be going into U7701 is working. All the resistors around it seem perfectly fine as well. Think. What else could this potentially be? Because this isn't boosting like it should, the feedback. So, probably gonna have to do this the old school way. And just pull off the driver and probe around. You know what? Does this even think that the screen's connected? What I mean by that is it gonna give me the same reading of 8.6 if the screen's not plugged in? I don't know, I'm curious. No, we get much different voltages. So yeah, it is detecting the screen. So that's not the issue here. I just wanted to make sure. So there's something else going on. Optimized logic says test point. I would scrape some solder mask off and check super close. Yeah, I do have a lot of flux right here. SMC Lid. Ah, I didn't even think about that. That's smart. Okay. So basically what Optimized Logic Repair is saying is SMC Lid, that is the part of the computer. It's triggered by the Hall sensor, but it sends a signal to the SMC, the System Management Controller, that tells you if the screen is actually closed. There's a magnet in the screen, and once it comes in contact with the Hall sensor, it will then send a signal to the SMC to dim the screen or turn it off because it thinks that the screen is closed. So that's actually a very, very good good point. So let's take a look at that point too. The one that has solder. What, the test point that we used? Let's Do you think that that test point might have a different type of it might be shorted a little bit? Because we did make sure that there is continuity for the feedback. Yeah, and it looks like this is all just fiberglass around it. Doesn't look like there's any sign of ground, and when I measured it with my multimeter and resistance, it seemed perfectly fine. So, don't know if that's the issue. Okay, so let's take a look and see where SMC Lid is located. Okay, so SMC Lid is going to be around the trackpad. For some reason, that's plugged into the trackpad. The I/O flex cable that connects the daughter board to the main motherboard, and then SMC, this resistor as well, C4835. Okay, so let's just examine these parts real quick. Wrong camera again. Okay, so that looks fine right there on our trackpad connector. That looks fine. Where it plugs in on the logic board from the I/O cable looks fine. The test point should be connected to where you were scraping. I'm sorry, I'm actually really confused. You said that where I was scraping, that was the test point because that's where we had soldered onto. But what exactly were you suggesting to check? Because we did do the continuity test and it looked like it was fine. It didn't seem like there was any obvious short. Anything obvious, at least. I'm sorry. Okay, let's see where on the schematic it is suggesting. Okay, so around here says our SMC lid is connected to. And let's just check the resistance of that line. And it looks like infinite resistance, so I don't think that's being triggered. Let's hook up our screen and see if it drops, though, after we turn on the computer. Alright, so we'll plug in our power supply, trigger it to turn on, and let's see what SMC Lid is doing. 3.4. So it doesn't look like SMC Lid is the issue here. That's a very good suggestion. So I'm going to treat this as if it was an iPhone. And what I'm going to do is I'm going to pull off our backlight driver and measure in diode mode to another board and compare the differences. That's what I was thinking to optimize logic repair, because we did have continuity, so I don't think the issue is over there. So I've solved plenty of iPhone repair issues this way, just by getting a good measurement from another device. I just got to find a donor board that still has all of its backlight circuit components intact without, and that doesn't have liquid damage around it. And Manuel, optimized logic repair, from what I'm reading in the corner of my eye, is correct. A fuse is just a safeguard. If you just end up replacing it, then you're just going to blow it again with another fuse. There's going to be something on either side of the fuse that is damaged, that is killing it. And it could be like the tiniest shorted capacitor. Now, in my opinion, though, the hard part about trying to figure out a short on PP bus without a microscope is going to be tricky. But also, you probably need a bench power supply that you could solder a wire onto PP bus and inject just 1 volt and feel around with your hand and feel what gets hottest. Or you can use 99% alcohol and see what melts the quickest. All right. Alright, so I've removed our driver, and now I just need to find a donor board that's in okay condition, and we're just going to compare side by side the readings of diode mode. So let me see if I can find one, because we can't use the donor board I've taken the capacitors off because it's going to read differently. We need to find one that still has its components still intact. And it seems like Water damage around the backlight is very common. And this one we've taken most of the backlight components off of. That one's also damaged.
So the wattage on stuff, the higher the wattage, the brighter it can be?
Wattage is power. So the more wattage you have, the more power you have. So technically, yes, if you have a higher wattage for a light, it is going to be brighter.
I'm looking into some strobes.
Okay.
I want to be able to tone it down if I want to. I don't want to be doing
Perfect, I found a board. All right, so we got a board here that looks to be in really, I mean, it's a donor board. It's going to be as good as you get, but it still has most of its backlight circuit still on. So now we need to remove this backlight driver. Donor boards are very interesting to acquire. AliExpress is a good place to find them. Find a local group on Facebook that might be selling them. Or if you are already in the repair industry, you might be able to buy back some broken computers from any clients or customers that you have. Yeah, once I get the diode measurements of this component, I should be able to figure out where the issue's at. I wasn't expecting to stay here an hour after closing. I'm sorry. Alright. So now, what we're going to do is put our multimeter into resistance and just start jotting down some numbers. So let me find a whiteboard real quick. That is a permanent marker. So when measuring in diode mode, you're going to put your red probe on ground, and you're going to measure with your black probe. Alright, so let's see what we get. All right, so that's OL. That's ground. OL. OL. And OL. Really? All right. All right, row 2. 0.6 OL, 0.35, 0.5, ground. So I forgot those last two measurements. 0.5 and ground. OL, 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 0.5, OL. Next measurements. Ground. OL. 1.9.
That's what they done on
1.9. OL.
She said he hasn't got the ring yet, but when he gets the ring, they'd like to do photos. And I was like, yeah, and I sent her that picture of Kyle, and I was like, can we do photos like this, but like with you guys? She's like, yeah! It's like, yay, we get to try dry ice again. Because we filmed it last time. I don't know how bad.
Yeah, that's awesome.
Yeah, so never even said it.
0.4, 0.4, OL. All right, so now that we have our handy dandy measurements from our donor board, let's compare on our patient board and check and see if they're going to match up similar or if they are off. This will tell us if our backlight circuit's working like it needs to and if there's another issue. So we should have OL right here. Ground, OL, OL. OL just stands for open line, by the way. OL. All right, next is 0.6. Got that. Then OL. Then 0.35. Got that. 0.5. Got that. And ground. All right, next is going to be OL. And OL. Open line. 0.5. Got that. OL. Okay. Next is going to be ground. Open line. 1.9. Got that. 1.9. Got that. And open line. Next is going to be ground. Open line. Have that. 0.4. Have that. 0.4 since it's the same line. And open line. All right. We don't have a backlight issue anymore. I'm thinking we have maybe an issue with the SMC. So I went ahead and we've compared our diode mode measurements of the backlight IC with the donor. And it looks like there is another issue here. So the backlight circuit, or at least the IC, everything around it, is working like it should. This one is interesting. To measure voltage, you need to power the board. You're not talking to me. Never mind. So, what is going on here? Oh my god. You know what? What would be the chances that this donor LCD that I'm trying to use also has a bad backlight? I don't think so. Okay. So... what else could be our issue here? Alright, let's take a look at PPVN SO LCD backlight. There was another part that went to a shunt resistor. Right here. R5490. So we have our PPVN SO LCD backlight. This should be working. But this looks like this is going to be some sort of, yeah, driver input current sense. Could this potentially be where our issue's at? Let's take a look. R5490. Yep, SMC is acting up. Potentially. It very well could be. We could try reflowing it. Or, I don't want to have to replace it right now because it's been going for about 2 hours and I'll need it at home. The wife is, or the boss is kind of just hanging out here. That shunt resistor does not exist. It even says omit. So, it looks like at least this line is going to go to U5490. Is that one existing? Yes, that is going to be right next to our driver. Nope, it does not exist. Okay, yeah, this looks like this may be an SMC issue. Okay. Let's see if we can take a peek at the SMC. Who knew that an SMC could cause our backlight to not work? Okay. I don't see any obvious signs of damage or corrosion. So maybe, in this case, this is going to be a situation where we're going to need to either reflow the SMC or just replace it. I'm gonna try reflowing it real quick. And then if that still doesn't work, we can try replacing it, but we'll probably have to just call it quits if a reflow doesn't work. Only because this is taking a little bit longer than I anticipated. And just, my wife's hiding right here. We're supposed to get some dinner. Wrong camera again. I like this channel because it's more like a real scenario. Paul D and Lewis R are so fast to explain things. They're really, really good at explaining. I definitely recommend watching them still. But what you want to do, in my opinion, is watch Lewis's earlier videos. He's definitely very, very busy. And so the videos that he shows you now, he kind of just explains really quick how the process works just so that he can get things done efficiently. He has so much more business than I do. So he doesn't really have the time to take to explain every single circuit, and I'm not on that level of explaining everything. Also, he's been doing board repair for over, I want to say he's been doing it for about 6-7 years. I've only been doing it for about 2 years now, so I'm still very much intermediate. I'm not reballing CPUs and GPUs. I'm just bringing MacBooks back to life, but I'm also still learning the circuits as I go about it. And I have awesome colleagues like Optimize Logic Repair and some other technicians in the Discord that are able to help me. It's exactly what I was thinking, was reflowing the SMC. So let's see if reflowing the SMC is going to bring backlight. At least we know that our drivers are fine. Now the question is, do I want to reball them, or am I okay with losing the $3 per IC? I just got a whole shipment of them in too, so to cut down on time, I'm going to hold on to them for later, but I'm going to replace it one more time with another good one. You can do it. Thank you. I appreciate that, Manuel. Now we gotta get this stuff that's just hiding right there in the corner. Yeah, another thing I need to add that Lewis has on his channel is a cheap alternative to certain tools. Because everything that I have now are things I've acquired over the year, but this is a completely different micro soldering station than what I had when we first opened up. I had a much smaller Amscope that only had a ×10 zoom, but it was enough to get board repair done. And as far as the fume extractor, I actually just recently upgraded fume extractors, but I got just like a $90 Hako compared to this one that we have now. And even my reflow station, the one I got, I think the name of it was Zenny. It's not even like a big name brand, but it never failed on me, and I was able to get plenty of board repairs done. So that is something I'm going to put, is just like maybe a starter kit, because this is a very, very expensive career to get into. There's a lot of startup cost. Basically, we just started off with decent repairs, or decent tools, and got to a point we did enough repairs we could afford getting better tools. Alright, so I've removed all of my edge bonding. So let's go ahead and get our SMC reflowed. A little expensive delivery to Chile. I can only imagine. I'm sorry, Chile, not Chile. I've been in the South far too long. And the horrible thing too is my brothers are fluent in Spanish. My name's Esteban, but I can't speak it that well. Alright, so whenever you're reflowing an SMC, you want to use a copious amount of flux. Just use a great deal, keep everything all nice and lubricated. Just hit it with a lot of heat. And don't just hold it in one spot, just go around in a circle, heating up the area. If this works, I'm gonna be so happy. Because it's all starting to make sense. If the rest of the backlight circuit is working fine and reading fine, okay, that's probably reflowed, then that makes me think that there is something wrong with the SMC. The clock in the data line that talks to the SMC has probably got some gunk under it from the previous liquid damage, or the SMC is just bad from having such dirty connections on it for so long. Alright, let's put the third LED driver on here. When I saw Esteban, I was thinking, yeah, a Spanish guy, it's gonna teach me. I'm sorry to let you down. Well, yes, I am Costa Rican. My father is from New York. We somehow ended up in South Carolina. Not that many people speak Spanish in the schools I went to. My name is Esteban Andres Millardo. It's pretty Hispanic, but I'm a disgrace to my fellow Ticos. Thank you, Manuel. That makes me feel a little better. Nope, nope, nope. Go back into your home. Nope. Too much air. Let's turn that down. Go back into your home. So if you guys have access to a quick 61 DW, that seems to be almost the standard, when putting BGA chip back on, I like to use between 60 to 80. That seems to be the right temperature to not blow a chip away. Okay, the driver's starting to move a little bit. Just want to see it do a little dance and fall into place. See if all right, and it just did a little dance right there, so we are fine. Yes, another tech, and I used that word loosely in this case. What they did is they took a little bit of isopropyl alcohol and cleaned it. That's what I was told. Now, this tech in particular doesn't really have the best reputation in town, but that's what I've been told, is it worked absolutely fine after that. Isn't that what she said?
No, she said that he cleaned it off, and it still didn't work. And then when she brought it in, the battery was not even connected, and the screen was halfway. The LVDS cable was halfway put in and halfway sticking out.
Okay.
So no, it wasn't working. I thought I heard you
Okay.
at all afterwards.
Okay. So the history on this one has actually never been fixed before. So it looks like the previous tech had tried cleaning it,
Yeah,
and that didn't fix it.
Yeah,
Okay.
it didn't fix it.
And
And
then,
he was going to do a screen replacement.
okay.
Yeah.
Well, that definitely wouldn't have fixed it.
Yeah, no, he was going to do a screen replacement. He quoted him for a screen replacement, and yeah.
Okay. So this one had the battery unplugged as well as the LVDS cable was slightly plugged in whenever it actually came in.
Yeah, it was like half plugged in, half not, and the battery wasn't plugged in at all.
Can you hand me that screen? Thanks. All right, let's see if this fixed it. All right, please work. If it doesn't work, then we'll replace the SMC, but I will do that tomorrow because I am hungry. Okay, that's plugged in. Let's get our charger. Fan spin. Depression. So I saw the LCD image did turn on, but still nothing. So at this point, we know that the backlight circuit is working like it should. So it's starting to look like maybe there is an issue with our system management controller here that is sending the wrong data line to the backlight driver here, which is why it's not turning on anymore. That's kind of what it's looking like. Let's try a different screen, Sammy. System management controller equals SMC. That is correct. I want to try some things real quick. Let's see what the connection looks like inside of the EDP cable underneath the microscope. All those pins look okay. Let's try another screen real fast. At this point, I'm just going to try some other diagnostics. I'm thinking too much as if this is just a straightforward repair. But Optimized Logic Repair made a very valid point. Someone else has worked on this. So let's just start from the beginning. Can't see screen. Unfortunately, it didn't work. Let's try a different screen. Okay, here's one. All right, this one says it has about LCD, so the backlight itself should still work. No, you're fine. You don't suck. This one is very different than what I've seen in the past. So let's try, out of curiosity, maybe a different screen is going to fix it. Shot in the dark. Let's see what happens. So this is a broken screen, so if it turns on, it should have lines in it. Yep, it has lines, but you can't see it. It's still not illuminating. I always try to triple confirm it's not an SMC issue, which ends up wasting more time in the end. Well, let's see. Yeah, still getting only 8 going to the EDP cable. So, for some reason, it's not boosting. And if we've checked to see that everything is working around our driver, then the only other thing it could be at this point is going to be something with the SMC. Yeah, because we have right here backlight clock, backlight data. That's going to be coming all the way through our SM bus PCH clock and SM bus PCH data. This SM bus, that does go to the SMC, right? Let's see where all this goes. This is probably the trickiest backlight repair I've been a part of. Tell me about it. SMCs are fixable if there is something damaged with the SMC. What you want to do is replace the SMC from a logic board, but it has to be the exact same logic board. It's the same 820 number. So for instance, you have an 820-00165, a 13-inch MacBook Air between 2015 and 2017. You have to use the SMC from a donor board of that exact same specs. Is fixable a real word? Everything is fixable. What does iFixit says? Never take broken for an answer. Okay, so back onto here. This line goes to U2201. It goes to a couple different places, it looks like, which makes its way to the PCH, which is built into the CPU. So this actually has nothing to do with SMC. Okay, what about this? Is this the same thing? SM bus PCH clock data. This board is making me mad. Tell me about it. I'm getting hungry. Huh. Okay, so this actually has nothing to do with the SMC. This is going to be going directly to the PCH. And when we measured in diode mode, D3, D4. Okay, hold on. Let's check and see if those were OLs. Let's go back. Which connection was this? Alright, that was connected to this resistor, which is 18. And then data is 19. Let me check my notes again. So, according to my notes, 18 and 19 were both 0.5. And those were perfectly fine. So the diode measurement between pin 19 and 18, which goes to the PCH, is perfectly fine. So I could say it's safe to say SM bus PCH data, SM bus PCH clock is not the issue. Okay, we did check EDP backlight power management. That was 2.8, because that eventually turns on backlight power management. Right? No, that was 1. Hold on, before I get things confused. PPVN SO switch back LCD backlight, that was 2.8. EDP backlight power management, I actually already forgot what that signal was. I want to say that was 1.4. Yeah, that was 1.4. I have 2 subs. It's kind of a snowball effect. Once you get one, they just start flowing over. I've actually had this channel for about 4 years now, but I've been a little bit more active lately. So it's only a matter of time. All right, R7704. Which goes to 4, which was 0.6. Actually goes to a couple different spots. Let me get another measurement on backlight power management. Yeah, 33. So that's doing what it needs to do. Let's see. We've already measured all these connections. Backlight enable was there. Backlight power management. Is that supposed to be 1.4? Let's see where this comes from. According to the board view, directly from the PCH. Oh, you gotta be messing with me. Maybe it's time to get some meal, Esteban. I'll second that. Huh. You know what? Let me take a quick gander near the PCH. Chris from Shiny Computers actually ran into an issue like this not a couple months ago, where he had no backlight, and it was because there was a data line right next to the PCH that had just a little bit of corrosion, preventing the VIA from actually talking to the rest of the computer. And it doesn't look like any signs of liquid damage. And like hell, I'm gonna reflow a PCH. It's like food over on this side. But it's not impossible. But the rest of the computer turns on. Okay, let's take one other quick look here. Okay, so we do know that the voltage divider is working, because I think it was like 3, which was turning on PP bus to go through our 8.6 line, which then turned into PPVN SO switch LCD backlight FET, which eventually turned into PPVN SO switch LCD backlight. There's a sense resistor between PP bus backlight and PP bus on the sensor page. We already checked that, and that sensor actually is omitted. It doesn't exist. So if that's going through D1, C1, we did check. We did in fact have 5 volts on both those pins. And then PP3B3SO. That's working like it should. So the VDDIO, VLDO, and VN are all working. Alright, so all this eventually turns into feedback, which is PPHVSO LCD backlight. Let's see where that follows later on up. Okay, so that eventually makes its way here, which goes all the way pin 3 and 4. PPHVSO switch LCD backlight. Just pin 3 and 4 right here, which we've already measured, which gets 8.6, so that's perfectly fine. LED returns. LED backlight display port. .3 SO switch LCD UF goes through a coil, which is also a sense resistor on page. What about this guy? Is this turning on like it should? Which is U8310. So pin 1 and 2 should be putting out 3.3 volts. Some sort of LCD switch, which then eventually goes back up into SM bus SMC. Okay, so the SMC actually does talk. Okay, so I could see how the SMC now is related to the display port backlight. But this is going to be data, I would imagine, which was working. Hold on. Okay. Let's check out our microscope camera. Just had to hook back up my power supply. Okay, so that tiny little IC, that little square, is going to be responsible for PP3v3 SO switch LCD. So pin 4 and 5, which is up here, is going to be what sends 3.3 volts to the LCD. So I think that's fine. I think it's communicating data just fine. But let's find out. Yep, 3.3 volts. So that's perfectly fine. So everything with data looks to be working just fine. Scrape, trace, and apply solder. Which trace are you referring to? Because this one I am a little lost. Just to make sure. I'm not sure what trace you're referring to. Are you talking about the feedback? Probably have to run a wire from the feedback. Just out of curiosity, making sure that these resistors for the LED return are all properly working. At this point, I'm just reaching. Okay, they're all working. Hello, do you have PP bus on both sides of fuse? Last I checked, I did, but you know, all of that could have changed. That would be embarrassing. Well, we have to, because last I measured, you know, it'd actually help if I had the screen connected. I did, but we'll check anyways. First of all, make sure it's not blown. Yep, that's a nice solid connection. PP bus is present on both sides. What about that tiny, crappy looking capacitor right in the center? What is that responsible for? PPVNS LCD backlight, which we know is fine. Oh, hold on. Hold on. Okay, 0.8. It was just taking a long time for it to actually turn on. Yeah, still 0.8. And these are just smoothing capacitors, that's all those are. That wouldn't affect voltage from the bump trace where you scraped earlier. Alright, we'll spend one more time looking at it. If that trace looks fine, then I'm going to do something with the SMC tomorrow, because the backlight circuit looked perfectly fine, especially using the diode mode readings. All that should be okay, which is why I think the feedback line should be okay, which is interesting. It's an OL. In fact, actually, let's just touch it with our tweezers. Is this nothing more than just a test point? Is that all that this is? Now let me wick that up real quick. I mean, it feels pretty solid. Doesn't look like there's any rust. And I'm just kind of scraping the fiberglass around it. See, I know it's a via, but what else does it connect to? Well, I shouldn't say I know it's a via. I asked you if it was a test point. Because it doesn't connect to the part next to it, above it, or below it. No, that'd be too easy. And it should be connected to D701. It's very possible at this point that it is a hairline crack. Just having some difficulty. Alright, I'm gonna try one last Hail Mary, Sammy, before we get on out of here. Alright, so what I'm gonna do just to rule out if this actually is an issue with the feedback, I'm going to run a jumper wire across the board. For this, we're going to need iPhone jumper wire. That should be connected to where you just scraped. Yes, it's supposed to. I think there's a delay in the video. That is broken, my friend. Oh, wait, which part's broken? This sounds very ignorant of me, but I don't see anything broken. Hold on, let me compare this to a donor board real quick. Because if you're right, then that means what I'm about to do. Oh my god, I see it. Thank you. Ah, you're right. You're absolutely right. Sorry, it was so clean of a trace. It looked like a test point more than a via. So here on our donor board, we can see. Oh my god. I see it. Okay, so just to show you real quick, Sammy. I'm an asshole. You see how you got this dot right here? And then you see this land bridge, we'll call it? You can barely see it, but you see how like it's not connected? This thing to this thing?
Okay. So how do you fix that?
You just put a giant blob of solder. Call it a day. No, we'll put a wire. But let's just go ahead and
What does that control?
the feedback, which tells the backlight driver how much power it needs to send out to the LCD, and it's completely severed. The thing is that was
Supposed to be digging into it like that?
I'd have to since I got to repair the trace.
Oh.
Yes.
What happened?
Corrosion. The amount of corrosion
So
was.
you just didn't see it?
No, I did see it, but the thing is, it was such a clean break. I thought that was how it was intentionally designed.
Yeah.
So I just compared it to a bad board, and it doesn't have that.
Okay, so where's that located on here?
In the same area where it was liquid damaged. Flip it back over.
Oh.
Right here. And that's where all the liquid damage was. Oh my god, I'm sorry for keeping you so late.
Oh.
Yeah.
Oh,
Yeah.
so that whole copper trace was just completely.
Yeah, yeah,
Okay.
you see that?
Okay, that's what I was. Okay, so yeah, that's where the
All the
that
corrosion
shop-
was.
Well, that's where corrosion was, but that's where the shop cleaned it. She actually has pictures. I probably could have just told her to send those to us.
It's fine. It's fine. We're going to put a very, very tiny little wire in
Yeah.
between the two of these.
Okay. Yeah, but yeah, she showed me before and after pictures because they took some. So.
Yay! We can. This one's actually pretty big compared to some of the wire I have. But,
That's enough to like hurt if it stabs you. Like
maybe.
Like a wire splinter.
Uh-huh.
Cool.
Yeah, which means we can clean hers tomorrow and she'll be happy. And we can get dinner. Okay, so just to be safe, I'm just going to put a tiny, tiny little wire in between, like a stitch. That sounds delicious. Barbecue chicken tonight. That was definitely it. Oh my god. Yeah, but like, the annoying thing is that optimized logic repair was right on the money from the get-go, that's what the issue was. Okay. No, I know. I made sure not to bridge the bottom part. Bottom part is not bridge. So I'm not even going to use this test LCD. Actually, yeah. Just because I want to get out of here. We're going to use this test LCD just to show you that everything is working. Just real quick. All right. Let's hook up our fan momentarily. And this is why you need a microscope in order to do this repair. You would have, oh my god, I don't think I would have been able to figure this out with my eyes. Okay, let's turn it on. Whipped out all the stops for this one. Alright, so this one's a broken LC. So we're gonna have like weird lines in the display when it finally turns on. There it goes. Backlight. Broken display. Let me go ahead and plug it into the customer's computer just to prove that that is working. What? Stop. Quit making fun of me. Okay. And this is why we charge a flat rate. That looked like that should have only took 20 minutes. And it probably would have with a more experienced technician. No, I'm just... Well, I'm so glad we didn't bother taking off the SMC, because nothing would have made me more angry than to reball that, only to have the exact same issue. That's why I try to quadruple check the SMC before we actually mess with it. Nothing is more annoying than fixing an SMC for no reason. Now, I apologize, Optimized Logic Repair, that I doubted you. I even said a few times, no, I don't think that that's the issue. Well, I was wrong. IDP cable looks like someone has bent it. Other than me, it could have been me, but maybe not. If it is bent, then we'll just end up replacing it. 3 hours of learning is good to me. Oh my god, we have been live for 3 hours. Jeez. This was supposed to be a quick 30-minute informative repair. So me and a couple of other technicians have decided that we want to try to make a little bit more informative videos on just how to properly diagnose, but also handle customers. Because you want to definitely do the right thing for customers, and they'll always keep coming back to you. And one of this video was supposed to be a quick, this is why this is a backlight issue video. Well, this is what I get for trying to make one of those videos. At least I showed you everything that could have potentially have gone wrong, everything that makes up the backlight circuit. So, one thing's for sure, I will never do that ever again. I will never make that same mistake ever again. Until next week, when I make it again. Oh my god. Okay, so we're not going to put everything back together. I'm just going to kind of leave it a little sloppy. And we're just going to clean the board tomorrow. But for now, let's see the option boot. It's everything that we need to option boot. All right, powered on. I already see a backlight, but here in a second, yes, 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 and that is how it is done.
Stop.
I'm sorry. Awesome. So, this one is working again. This one originally had some corrosion around the EDP cable. That was part of the problem. There was a couple of things, but that was pretty much the main problem. So we went through the process of troubleshooting the backlight. And so what we did first was, verify. My name is Tim, by the way. Thank you, Tim. Thank you so much. So we're hold on. I need to regain my thoughts. It's been 3 hours. So basically, what I was trying to show here with the video, customers are gone. I'm going to take this off. is pretty much how to troubleshoot the difference between a bad backlight and a bad LCD. And basically just making sure that there is power going to the LCD. I can't even remember the name of the line right now. My brain's so fried. But make sure it's either 2 volts, 8.6 volts from PP bus, or the full 20 to 55 volts. Well, in this case, we had 8.6. So that was enough to tell me that the LED driver, what actually turns on the backlight, was trying to work. But it just was not getting boosted. It was not getting enough power to push out to convert 8.6 volts to the needed 15 to 55 volts of power. So before we went any further than that, first thing you want to check when it comes to backlight is, do you have continuity across your fuse? Your fuse that connects PP bus to your LCD switch SWSO backlight enable. I don't remember the name of the line off the top of my head. If that fuse is perfectly fine, and I can actually show you here on our schematic, you want to check for this fuse and make sure in continuity mode with the battery unplugged, power not in, that you have a beep or 0 ohms, 0 resistance across this line. Next thing you want to make sure is that this line with the LCD connected is not shorted. You can either test right here, directly where this capacitor goes into our PPHV-SO switch LCD backlight. If it is not shorted, then there's going to be something further with the board. If it is shorted, then you want to unplug your screen and check your LCD connections. If the connections look dirty, and then the EDP cable looks melted, probably going to have another board issue with the EDP. Or EDP port. If the cable itself is bad, then you probably have a bad cable, and I could do another video on how to replace that. It's not a fun repair, but it's doable. But if you remove your screen and then all of a sudden the short is gone, you actually have a short in your EDP cable, so therefore it would be a screen issue, which was originally diagnosed by another repair shop. So the screen would not have fixed this. In this case, to take it all the way back down, this tiny little via, and this via connects to the other side of our LED driver, right here, pin 5, and there's a tiny little via. It's just a hole that goes from here to here. Pin 5 is responsible for our feedback. So feedback, if we look here on our schematic, this is going to be basically a signal that tells how much power needs to be sent out of the switch 0, switch 1, to the rest of the device. This is basically what sends 8.6 volts to about 15 or 55. I'm actually still learning how the feedback circuit properly works, but that's pretty much how I understand. So in this case, this line right here, this is actually where the board, it goes through the board on the XW7720. This actually isn't a component. This is just a via that goes through the board. It was severed. So it was completely severed. We weren't getting a connection between our feedback line on our diode, the pin 2 of D7701, to our pin 5 of our feedback. So since that was completely severed this entire time, it was not turning on the rest of PPHV-SO switch LCD backlight. Pretty much went through all the diagnostic processes here to figure out why this wasn't turning on. We even went as far as thinking of what if this was like an iPhone. Just pull off the BGA chip, do diode mode. Unfortunately, what trolled me here is that on a normal board, that line for feedback is open line. So when it is already severed, it is open line. I think the only way I would have been able to test if this was to get a different reading than OL is if I actually had the LCD plugged into it. I'll have to test that out, and that probably would have pointed towards the feedback being the issue in the first place. But anyways, this was a very fun yet strenuous process of doing a backlight board repair. Thank you for the people in chat, especially Tim here, for helping me out, because this one was very difficult. I overlooked that via far too many times, even though he had told me pretty much I was making an ass of myself to check that via. So thank you so much for joining me this evening. I'm going to go get some food because it is 2 hours after closing. And yeah, thank you so much. I'll see you guys in the next one.